so far, everything that we've been dealing with has been rational or real numbers. Real numbers are like the number 0, 5, -5, 1/2, 3.2, -2.5. They're real tangible numbers that you can measure, right? You can touch. Now, complex numbers are consisting of numbers called imaginary numbers. So they're numbers that are not tangible. You can't really measure it. And the story that goes with complex numbers is that mathematicians, scientists, astronomers, physicians, all this stuff, when they started solving problems like taking people to the moon or circling a satellite around the Earth, it takes a lot of math. Haven't you guys seen Hidden Figures? Mm-hmm. Right. And as you can see, like a lot of the stuff has to do with math, right? When they're trying to figure a lot of that stuff out. So they're solving equations in order to get people to the moon, in order to get a satellite up in the air. It's all mathematics. So there came a point in math where they hit a wall. They hit a wall in math that it was impossible to keep solving a math problem, and they didn't have the tools for it. And specifically when they came up with the radical of a negative number, because the radical of a negative number does not exist in real numbers. So either they discovered or they invented, depends on how you look at it, they discovered there's another realm of math, another realm of numbers called complex numbers that has imaginary numbers, and that by having these imaginary numbers in place, we were able to pass that barrier of solving problems that had negative radicals in it. And it opened up a whole new realm of being able to solve problems and take people to the moon and fly a satellite. So I kind of think of this, quote unquote, one way to think about it is kind of like the spiritual world of math. So real numbers are things that are tangible. And in the world of math, it's kind of the spiritual realm where you can't really see it, and it's invisible, but you need it, right? You need it, especially when you run across problems that you can't solve. You need to access another realm of another reality to help you pass this problem. So here we have, the definition of this is I is equal to the square root of -1. Because in real numbers, the square root of -1 does not exist. Because square root means two numbers that are the same multiplied together will give you the thing inside the radical. So if I multiply -1 times a -1, you get a +1. You can't multiply anything to give you a negative number, right? So that's why we have this thing called I for imaginary number. So I squared is if you square any term, if you square any radical, you'll get the thing inside of it. The inside is called a radicand, and if you square it, you'll get -1. So if you square this imaginary number, you can go back into becoming a real number. So the imaginary number here, when you square it, it becomes a real number. And that's how the simple truth, the simple quote unquote spiritual truth opened up realms of possibilities for mankind. So here, those are the two facts that you just need to know, right? So here I kind of explain it a little bit more. The square root of 4 is 2, since 2 times 2 is 4, right? Square root of 16 is 4, since 4 times 4 is 16. That's how radicals work, right? Any two number multiplied together should give you the inside. The square root of 1 is just 1, right? Since 1 times 1 is 1. What's the square root of -4? 2i, right? So there is no real solution, right? So there's no real solution that will give you the answer to square root of -4, because you can't multiply any two numbers that are the same to give you -4. So you would say no real solutions and be stuck, and then there goes the moon, right? There goes the satellites, there goes all these things. However, if we allow for complex solutions, if we allow for it, I heard Wyatt say that the square root of -4. So what you're going to do is you're going to separate the real from the imaginary part. So the problem's a negative square root, right? So the negative square root times the square root of 4, that'll give you this. I just separate the negative 1 and the 4. Do I know what a square root of 4 is? 2, right? That's no problem. And what is the square root of negative 1? It's just I, right? So therefore, my answer was just be, it'll just become 2I, right? Because the square root of 4 is 2. And then you can write the I before or after it, but normally we like to write it after 2I. Right? So, and then in terms of how did this come about, right? How did this come about? So I'm a person that doesn't like to memorize math. I like to understand it. The only thing I memorize is really this one. And then when I think of what is I squared, how did it come up with this? If you think about it, square root of 2 times square root of 2 is the same thing as putting under the same radical. That'll give you the square root of 4, which just goes back to 2, right? So if you have a number multiplied by itself in a radical, the answer is just the number itself, the number 2, right? And this is kind of the proof for it, right? So if I ask you what's the square root of 10 times square root of 10? It's just 10. But if you wrote it all out, kind of the logic, why is the answer 10? Why is this answer 10? Well, if we saw what's 10 times 10? Square root of 100, right? And the square root of 100 is 10, because 10 times 10 is 100. So if you just keep going forward, square root of 5,000 times square root of 5,000, shortcuts, skip the middle stuff, you end up getting 5,000, right? Shortcut. Okay, what do I do with variables? Square root of x times square root of x will give us this x. Let's do with symbols. What's the square root of heart times square root of heart? Heart, right? And that is why, so I'm just giving you guys the logic of that is why when you do I squared, when you're doing square root of -1 times square root of -1, you end up getting just a thing inside, which is just -1. Right? And that is why I squared equals -1. It's not just because, right? So this is just an introduction to show you these two things that you need to know. Now, we want to be able to, when you write out your answer, they always say, write your answer in standard form. So standard form is like this. It's A and plus or minus, depends on what the problem, BI. And the A and the B are just numbers. So the first part of your answer is always a real number. And then the second part, the BI part, is the imaginary part. So you always want to write your answer in that order. If you write your answer in a different order, you'll get it wrong. So there's a standard way of writing it. So let's do a problem. The square root of -9, I'm first going to separate the negative outside, because the negative is what's going to give us a problem, right? So I'm going to separate that, and I'm going to say -1 times a +9. Right? So I can separate the radicals. I can separate the negative from it. Square root of 9, what is that? 3. No problem. Square root of -1, I. So I times 3, or we could write it as 3i. Right? It's not too bad, right? Okay, let's make it a little bit harder. So that's a perfect square. 9 is a perfect square, so it's a little bit easier to find. But what if it's not a perfect square? So here I have negative square root of 24. So first I'm going to separate the negative. So -1 times 24, square root of 24. I know there's going to be an I, right? That's the easy part. What's the square root of 24? It's not a perfect square, right? There's no two numbers that are multiplied to give you square root of 24. So review of beginning and intermediate algebra. How do you find the square root of something that's not a perfect square? You need to split this up into a perfect square number and a non-perfect square number. What two numbers multiply to give you 24 where one of them is a perfect square? 4 times 6, right? So square root of 24, I can rewrite this as square root of 4 times square root of 6. And the reason why I did that is because one of them can be simplified because it's a perfect squared. What's square root of 4? 2. Okay, I have the I here. Square root of 6, can I simplify that anymore? No, right? So now I'm left with this. So now I'm going to write it nice and pretty. 2 times I is just 2I sitting on the outside. And inside I have the 6. I'd like you guys to try square root of negative 52 and square root of negative 18. Go ahead and try that. So now we're going to start talking about adding and subtracting. So this is now adding and subtracting complex numbers. So here I see an addition sign, and here I see subtraction sign. So because we're dealing with another realm of math, yet we can't assume that it's going to be exactly the same as real numbers, right? We're like, do they behave the same? Is adding, subtracting, multiplying, dividing the same? And thankfully, the answer is mostly yes. When you're adding, subtracting, or multiplying, they act exactly the same as the real number system. The only thing that's different is dividing, and we'll get to dividing later. So here, when you add or subtract, you treat the I like it's a variable even. So the nice thing is it's the same thing as real numbers. So here, we just add the like animals. What are the like animals? Okay, negative 4i and 5i. So what's negative 4i plus 5i? I, right? Plus I. And what's 3 plus 2? 5. And I wrote it in this order, 5 plus I instead of I plus 5, because we want it in the form where the real plus the imaginary, right? Can you add these two together? No, they're not like animals, right? So same rules as real numbers. Okay. So now let's go on to this one. If I have a subtraction sign, what do you do when you have subtraction sign on the outside? Right, you multiply it through, you distribute it through. So let's go ahead and try distributing. You get negative 5 plus 7i. The beginning doesn't change. What happens after that? The negative 11 becomes a positive 11. The 2i becomes a negative 2i, right? So same thing as regular numbers. Combine like terms. What do we combine? Negative 5 and 11, that'll give us 6. And then what's 7i minus 2i? Plus 5i. And that's it. Okay, part E here. 4 multiplied by this whole thing. We just distribute. Go ahead and try that. What do we end up getting? 8 plus 20i. Any questions? So this one, now we need to, what's that acronym that a lot of people say? FOIL, right? You can FOIL it. Well, really, it's just distributing twice, right? Take the 4 and you distribute it through first and outer. What do you get when you do that? 4 times 2 is 8. 4 times negative 5 is negative 20i. First, outer, inner, last. So then you take the second number and you distribute it through. So just doing distribution twice. And what do you get when you do that? Plus 6i. I squared, right? So I times I, this is gonna, a little bit of a newer part. I times I gives you I squared, just like x times x is x squared, right? So same rules of real numbers, so which is good. Now, what is I squared equal to? Negative 1, right? So whenever you see an I squared, you just replace it with a negative 1. So here, I'm going to have negative 15 times negative 1 since I squared is equal to negative 1. What's negative 15 times negative 1? Positive 15, right? So now I have 8 minus 20i plus 6i plus 15. So that's the only kind of new thing that's kind of different. I squared replaces negative 1. Go ahead and combine like terms. What do we get when we combine like terms? Okay, so 15 plus 8 is 23. Negative 14i. Great, and I'm glad you did it in the right order where you added the real numbers first and then the imaginary numbers afterwards. Okay, all good in the hood? Yes, all right. So that's smooth sailing. Let's go to the next part. So now we do division. So I wrote a few of these steps here. There's some words up here, but I wrote it out as well so you could have notes. So when you divide with complex numbers, so fraction means division, right? You're like, where's the division sign? Fraction is division. So what you're gonna do is, when you divide, we do not want I in the denominator. So we must get rid of I in the denominator. So what do we need to do? We multiply by the conjugate of the denominator to get rid of I. So what is a conjugate? The conjugate is if you have a number, say 7 plus, or an expression 7 plus 2, you change the sign in the middle, just the sign in the middle. So 7 minus 2. If I had the conjugate 4 minus 2x, what's the conjugate of 4 minus 2x? 4 plus 2x. Here in this problem, I have 4 minus I is the denominator. 4 minus I is my denominator. So what is the conjugate of 4 minus I? 4 plus I, right? So we change the middle sign. 4 plus I. So here in this problem, I'm going to multiply everything by the conjugate. So when I multiply by the conjugate here, I'm going to get 4 plus I times 4. And whatever you do the bottom of the fraction, you must do to the top. So whenever you're multiplying anything, the rule of math is whatever you do one side, you do the other. Whatever you do bottom, you do the top. So 4 plus I, because it's the conjugate. This is the conjugate of 4 minus I, right? And we're like, what does that do, right? So let's try that. So the numerator, so let's do the denominator first. The denominator, when we multiply this out, we have 4 minus I times 4 plus I. And the reason why we're doing this is to get rid of I. We're like, what? How does that get rid of I? That just made it even uglier, right? So let's try it. Go ahead and FOIL it and see what you guys get. First, outer, inner, last. What's 4 times 4? 16. What's 4 times I? 4i. Inner, what's negative 1 times 4? Negative 4i. And then what's negative I times I? Negative I squared, right? What's I squared? Negative 1. So I have a minus of a negative 1. What's a minus of a negative 1? Positive 1, right? What else do I notice? What cancels out? Okay, the 4i and the negative 4i becomes a 0. And this will always, always, always happen whenever you multiply by conjugate. The middle terms are always, always, always going to become 0 because they cancel each other out. So we're left with 16 plus 1. And what's 16 plus 1? 17. Are there any i's? No. So, badam. The denominator, we have 17. Right? This has no i's. Now the top, it's okay to have i's on the top. So the top is okay to have i's. So here the numerator, 2 times 4 is going to give me, so let me write this on the side. The numerator, just because there's not a lot of space, I have 2 plus 5i multiplied by 4 plus I. 2 plus 4 gives me 8. 2 plus I gives me 2i. And then 5i times 4 gives me 20i. And then 5i times I gives me 5i squared. Do the middle terms cancel out? Do these cancel out? No, right? It only cancels out in the denominator when you're multiplying by the conjugate. On the top, you're going to get some funky monkey answer, and that's okay. The top could look ugly, but the bottom needs to look like just a number. So if you come, what's I squared? -1, so 5 times -1, so that'll give you -5. So let's go ahead and combine like terms. Three plus 22i, right? So 8 minus 5 is 3. 2i plus 20i gives you 22i. So I'm going to write 3 plus 22i. Is this my final answer? Yeah. Not quite. We need to have it in a plus bi form. So a plus bi form, right? So that means that you need to have the real part plus the imaginary part. Well, you're like, well, that does look like real plus imaginary. Well, not quite. It has a fraction underneath it, 17. So if we want to split this into 2 fractions, what does this become? 3 divided by 17 plus 22 over 17i. And that, my friends, becomes your final answer. There's your real part and there's your imaginary part. So you have everything underneath one fraction, make sure you split it apart. And this is legit because the 17 is in the denominator. It could become 2 parts of 2 fractions. When you write out your answer in Newton, you can put the I on the side or you can put it on top. It doesn't matter. As long as it's the second part of the answer, not the first. Let's go ahead and have you guys try the second part. And feel free to work with your neighbors. Feel free to check your work with other people. Next up is to simplifying complex numbers. So in math, we always want to simplify our answer to lowest terms. So like if we had a fraction, right, 4/8, we always want to simplify to 1/2. So we always want to simplify these things to lowest terms. So in complex numbers, it's the same story. You want to simplify things in lowest terms. Now, when you simplify things, the thing with complex numbers is that it kind of goes around, the answers go around in a circle. So we call that like a clock, right? If I asked you, what time is 13 o'clock? 1 p.m., right? 1 o'clock, that's army time, right? What if I said it was 16 o'clock? 4 o'clock? Okay. What if I said it was 23 o'clock? 11 p.m. How did you guys know that? How did you guys know that? Like, what mathematically, what did you guys do to get those answers? I'm sorry? The clock goes around in how many, what cycle? The cycle of 12, right? So after the number 12, then you know 13 is going to go back to the 1. 14 is going to go to number 2, right? So in terms of military time, they do that as military time. But in terms of us, in layman's term, we just use the clock cycle, right? With an AM and PM, right? So complex numbers also goes around in a circle. And it goes around a circle in 4s, in a sequence of 4 numbers, right? And that, luckily, it's not 12. If I say to simplify I to the 6th power, right? So what I'm going to do is I'm going to say, note the pattern for imaginary numbers. It's going to be a clock. It's going to be a clock that repeats its value in fours. So let's check that out. So I'm going to have a clock here. I'm going to put here the 4 numbers. And I'm going to go around in a circle. I'm going to go around in a circle. So the first number is I, right? I is just I, right? What is I squared? So yeah, I squared is just -1, right? Now if I raise the power again, and then I increase the power, I said I to the third. Well, to find out what I to the third is, I'm going to use what went before it to rewrite I to the third. So in terms of the rules of exponents, if I'm going to use the things before it to make it into I third. So I'm going to write this as I squared times I to the first part. Because the rules of exponents, just a review of some prerequisites, the rules of exponents says that if you have 2 things of the same base, you get to add the exponents together, right? That's the rules of exponents. So here, 2 plus 1 will give me 3, right? And that's why this works. So I could write I to the third as I squared times I to the first power, because 2 plus 1 will give me 3. Now, what is I squared? -1. So we're using what we just did, right? And I is just I, right? So what's -1 times I? -I. So I to the third is equivalent to -I. Let's try I to the fourth. So using the rules of exponents, how can I rewrite I to the fourth? Using I3, I2, or I1? Okay, I squared times I squared. Bless you. I squared, or you could say I to the third times I to the first, right? I to 1 will be fine. What's I squared? -1 times -1. What's -1 times -1? Say again? Positive 1. Positive 1. All right, so let's try I to the fifth. So what is I to the fifth? So my proposal is I to the fifth is equal to I. My proposal is I to the sixth is I squared. I7, I8, but let's verify that. Don't take my word for it, right? I to the fifth, how can I rewrite I to the fifth using what went before it? Okay, I to the fourth times I to the first. Sure, we could do that. We could also write I to the third times I to the second. Doesn't matter. What's I to the fourth? 1. I is just I, right? What's 1 times I? I. What do you know? It is this. So I to the fifth is that one also. My proposal is I to the sixth is -1. Let's prove it to ourselves. How can I rewrite I to the sixth? I2, I2, I2. Okay, we could do that. I squared times I squared times I squared. We could do that. As long as you're using the rules of exponents, it's legit. And what is I squared? I squared is -1. What's -1 times -1 times -1? -1. So we could do this on and on, but I hope you guys are convinced at this point that this will be I7, I8, I9, I10, 11, 12, blah, 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 on and on. So when it says to simplify I to the sixth, I to the sixth is equal to -1, right? And that's how you find out. So we already know you can start off. This was I, this was -1, this is, what is that? -I, and this is 1, right? This is where you start. and then you go around. So go ahead and count 18 times. What do we end up going? I hear people say negative I. Do you guys agree? Negative 1. Which one is it? So start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Negative 1. Everyone agree? Okay, to the 350. Do you think we want to do this 350 times? Hells no, right? Thank the Lord for brains and for patterns, right? So let's find out. Let's find out. I to the 18. Can I find out it being negative 1 without going through the circle? So let's use our brains. I'm not going to give you guys the answer. What do I have to do to realize that I go through this so many times and I'll land at negative 1? Divided by what? 4. What do I divide? 18 divided by 4. And the reason why the number 4 is because it's 4, right? It repeats itself every 4 pattern. So I'm going to say we can go through the circle, go through the clock, or we can do this. We do 18 divided by 4, and we divide by 4 since the clock, quote unquote, the clock repeats after every 4th power, right? So what's 18 divided by 4? 4.5. So 4.5, but let's say it in remainders. 4 remainder what? 4 remainder 2. So what that means is that we are going to go through this loop how many times? 4 times. We go through this loop 4 times and we're going to end off right here. So 4 times is right here. But then we take 2 extra steps because it's remainder 2. We take 2 extra steps to go uno, dos. We end up at negative 1. If it was a remainder 1, my answer would be I. If it was a remainder 2, it would be negative I. If it was a remainder 3, it would be negative I. Negative I. There's no such thing as remainder 4 because that means it would just be a whole number. So we look at the remainder. So the remainder will tell us to take 2 extra steps. Take 2 extra steps after the end, right? Because we end at 4 times. We end right here, and we take 2 extra steps. Uno, dos. So let's try that with I to the 350. So with I to the 350, I'm going to do, what am I going to do? Divided by 4. So it's 350 divided by 4. So if you put it in your calculator, you're going to get a decimal. So we don't want decimals. So I'm just going to do it by hand because I really think there's a value with learning how to do math by hand and not just your calculator. What's 35 divided by 4? 8. What's 8 times 4? 32. I subtract it. I get 3. It carries down to 0. What's 30 divided by 4? What's 7 times 4? 28. What's my remainder? 2. So 87 remainder 2. I don't care about the 87. It just means that I just went through this 87 times and I landed right here. I take 2 extra steps. So where do I land on? Negative 1. So this one ends up being negative 1 as well. I to the 35th and I to the 44th. So we already did this. We said this was negative 1. Right? This is written out in a different way. Someone else wrote these notes. So if you don't like how I wrote that, go ahead and just do those. Do that 4 circle and a clock thingy. Right? Remember, we start here. I to the 35. When you did 35 divided by 4, what do we get? 8 remainder 3. Okay, so if you guys have plugged this into your calculator, you might get a decimal. 35 divided by 4 is 8, right? And you're like, what's the remainder? So you do 8 times 4 is 32. You need to take how many extra steps to get to 35? 3, right? So here, I went through this 8 times and it ended right here. So remainder 1, remainder 2, remainder 3. So we're at negative I. Any questions? I to the 44. This is the one that Wyatt had a question on. What's 44 divided by 4? Remainder 0. So there is no remainder. So that means that you go through this 11 times. And when you go through 11 times, you end at this one, at 1. So your answer is 1. Let's look at this one. If you guys can't see it, it's I to the negative 20. Right? Like, what the heck? How do I do this? So one of the things I love about math is you just manipulate it, right? It's just a game of just manipulation. We're giving you all the tools, and the more tools you have, kind of the more weapons and the more tools. Yeah, the more tools you have to combat your enemy, right? The more that you have. So negative 20, I'm gonna rewrite this as with something that's positive, right? Because I could deal with positive numbers. And I know I1, I2, I3, I4. So I'm going to rewrite something with I1, I2, I3, I4. I like the number 4. Because if I write the number I to the 4th, I can raise this to another power. So this is the power rule. So power rule of exponents. So this is a review. If you have am raised to the n, you multiply the exponents. So this is a prerequisite skill, I'm review. So you get am times n, right? So if I want negative 20, what do I need to multiply this by to get a negative 20? Negative 5, right? Oh, sorry, this is a positive. This is an I. This is part of the I. Yeah, sorry. So I to the 4th raised to the negative 5 is the same thing as writing I to the negative 20. I just manipulated it to make it look like something that I wanted to look like. The power of math. And what is I to the 4th? 1. And what's 1 to the negative 5? So 1 to the negative 5 power. So again, another rule of exponents, it's called the negative exponent rule. The negative exponent rule says that if you have anything to the negative exponent, anyone know what you do with it to make it positive? Switch it to the denominator. Bring it down to the denominator to make it a positive. So when I do that, I'm going to get 1 over 1 to the positive 5th power. What's 1 to the 5th power? Just 1. So my answer is just 1. So using the negative exponent rule, how could I rewrite this? I to the negative 13. Right. So let me see if I can manipulate this to have something that I want it to look like. Let me give you guys just a chance to struggle with this. You want it to look like I to the 1, 2, 3, or 4. What can you do with the negative 13 so you can have it to the power of 1, 2, 3, or 4? Raised to, what can you do? So we have the power rule of exponents, you have the negative rule of exponents. And then we also have the product rule of exponents. So the product rule of exponents is where you have a to the m times a to the n, you add the exponents. Let me give you guys a chance to kind of struggle through that.